Hi, I'm Dr. S. Dhanabal, Professor and Head, Department of AI&DS, Kalinya Karnataka Institute of Technology, Coimbatore. We are going to see the introduction about database management system. Uh, the topic that we are going to cover in this course is the need for databases, data models, and relational databases, database design, storage manager, query processing, and transaction manager. So out of these topics, I'm going to take introduction to DBMS today. And we all know that data is scattered all over the world in the form of through social media, okay, Facebook, your YouTube, or whatever the things you have, Instagrams. Okay, all those things are capturing the data, and those data should be managed. Okay, so but actually we are not going to manage in the form of a table format. Okay, when the database concept was initialized during 1960s, 70s. Okay, we store in the form of a file system which was lagging in certain things. So later on, we are moving on to the database management concepts. Okay, so what is that database management system? It contains the information about a particular enterprise in which it collects the interrelated data. So using this interrelated data, we have a set of programs to access the data, and there is an environment that is both convenient and it is efficient to use. That type of environment we have to create. For example, the user doesn't know how the data is going to be stored and retrieved, but we have a system. Okay, we have a set of programs. Whatever the query given by the user, it will be taken by the set of programs, and it should be uh, analyzed and accessed at the back end, and finally it will be returned to the user. So this is the concept of DBMS. Okay, so we cannot avoid DBMS in any field. Okay, so database applications. Here we have certain applications: banking, airlines. You all know that, universities, sales, online retailers, manufacturing, human resources. In all these areas, database plays a vital role. So databases can be very large, as we all know that we are moving on to big data concepts. Okay, and where a huge volume of data is stored, and we are having a modern technology to access the data. But for finding the base where the data is managed and how it was accessed, okay, so that we must know. So for that only this subject is all about. Database touch all aspects of our life. Okay, so this is the most important concept of this. So important let me take an important university database application programmer examples. For example, if you take an university database, we have a lot of students, we have instructors and courses. Okay, so where we are going to add new students, where we are going to add, remove instructors, and we can able to add courses, remove courses, all those things. Okay, you can also modify the courses. Even you can register for the courses, and you can generate class rosters, and we can also calculate the grade points, and we can generate transcripts, all those things. But in the early days, database always were built directly on the top of the file system. So, but as we all know that file system has certain drawbacks, and these are the advantages of database management system, the invention of a database management system. So data redundancy and inconsistency is the most important thing. So where the data is repeatedly stored, when you take a file system, so I have to repeatedly give the data again and again. That will lead to the same data is multiple times it will be stored in the database. Okay, so that is the thing. So whenever I'm going to take, for example, if I'm going to modify one data, I have to modify all its copies. So that is the problem in the case of data redundancy and inconsistency. So the data becomes inconsistent, because if I skip to update any one of the database or files, so automatically I will not get the exact data. So there is the problem in the case of file systems, and we have a difficulty in accessing the data. So we need to write a new program to carry out each new task. Okay, so whenever I want to analyze something, I have to write a new program. So every time I have to write new programs to get the data. And data isolation is another one where we are having a multiple files and multiple formats are there. So we cannot able to isolate the data. Okay, so that is another problem. Integrity problem is another one. Okay. So whenever, for example, if my account balance goes below zero, so that shows that so I don't have any balance in my account. But this cannot be done using our programs. Okay, so this is in the case of file system, it should be completely buried. Okay, so it cannot be explicitly state. Okay, so that's what we have, and it's hard to add new constraints or change existing ones. So if I want to add, I have to rewrite the whole coding. So that is the problem in this case. And apart from that, atomicity of updates. So for example, if a transaction gets failed, for example, I'm going to transfer some amount from A to B. The amount is debited from A, but it is not credited to B. So what happens? So automatically it creates problem, no? So in those cases, those transactions are considered as incomplete transaction in the case of DBMS, and those transactions are completely removed. Okay, so again the database will be updated. Whereas in the previous system, it is not possible. In file management system, that is not possible. So the database become inconsistent. So once it's a partial transaction occurs, so all those things are kept as such. So that is the problem with the atomicity problem, what we are calling it as. And the concurrent access, that's what another important thing. So if you take a banking applications, you all know that millions and millions of users are accessing. So that cannot be done in the case of old file systems. Okay, so that is another problem with the file management system. Okay, so if two persons want to read the balance and one want to send money and another want to receive some money. Okay, so both the transactions will not occur. So that is not possible in the case of file systems. So in those cases, so it will give the wrong balances, and we have a security problem. So we cannot able to give or grant privileges to the users. So that is another important thing that we have in this case. And for all these problems, we have one solutions that's what the database system offers. Okay, so here we have three different level of abstractions. One is physical level, logical level, and view level. So this is the thing what we have in the case of physical level. Okay, the database can be viewed at the system level. So we all know the database administrator who has the right to view the data at the physical level. Logical level is that uh, the data that can be viewed by the programmer. So he wants to have the field name. Okay, he doesn't want to have the what is the data to be stored. Okay, what is the balance of any client, whatever the things he doesn't want to know. But the programmer knows how to store the data. He just collects the data from the UI or UX, and it will be sent to the backend. Okay, he will not, he doesn't care about the data. Rather than he is concentrating more on collecting the data using the field names. So logical level is highly completed, or logical level is highly related to the programmers, and view level is the place where the user directly interacts with the database management system. Okay, so for example, the views may vary according to the user. For example, the customer have certain rights to view the data, whereas the manager has some right to view the data, whereas the clerk has some rights to view the data. So all those things can be viewed in different levels. So this is the level where the user directly interacts with the system. And when we are coming to the instances and schema, okay, so we have a programming language where we have a data and all. we have a logical schema. So the logical schema is the overall structure of the database. Okay, so it will give the overall structure of the database. For example, if I'm taking a customer account, okay, so the customer account will have a customer ID, okay, his name, his related information, okay, for example, address, his age, okay, his PAN number, the number, whatever the things, he will, all those informations are stored in under a branch name. Okay, so that's what the logical schema what we are having. So in the logical schema, we are having the data in the form of field names. In physical schema, the overall physical structure of the database. Okay, so where it is stored, under who was created, at what time it was created, who has the right to access the database. All those informations are given by the database administrator. These informations are stored in the physical schema. Instance, what we are calling it as. So the database, when you take a banking application, so every time it is going to be updated. Okay, so whenever any new transaction occurs, the information is going to be updated. So what we are going to do, if I'm seeing my balance at 11 o'clock, it will show some balance. Okay, after some transactions, if I see my balance, it will give some other balance. Okay, so you cannot say that it is not consistent. But in this case, actually the query that we are asking to the database will give what is available at that particular time. Okay, so whenever you are asking the same information later on, that will not help out. Okay, so that is the thing that we are having. So the query that you are executing, you are getting some result. It is only for that particular time. That's what we are calling it as instances. Okay, and physical data independence refers to that. You all know that we have a logic schema. Okay, so the overall structure of the database, so that cannot be altered without changing the logical schema. Okay, so without changing the logical schema, uh, we are changing the backend. It means it is called as physical data independence. Similarly, we have logical data independence.